Alrighty, folks, now that I've unmuted myself and I'm not talking to just myself, let's get going. Let's see, I need to share my screen. Zoom has updated recently and it is great and also confusing. So, all right, so, I guess it's been a while since I've seen y'all. We missed Monday. I apologize for the last minute heads up on that one. I was unavailable that day, but hopefully from last week you were able to complete our assignments. If you hadn't, been to all of the workshops, hopefully you were able to watch the videos and make up those assignments as usual. But also, I hope that you have had time, or at least you plan to make time to, number one, study the practice test, and then actually retake the PSVT, right? The spatial visualization test. That is available on Canvas if you have not already done that. Again, keep in mind, right, that I'm going to be looking at whether or not you've submitted your assignments before I, am cool with, grading your new test, right? So it doesn't count if you haven't done the work, right? It's just kind of an incentivization. But, I think that I recognize a lot of familiar faces here. I think that I'm not too worried about that thing now. And also, again, right, call me, email me if you are worried about that or anything like that. I'm totally flexible. I don't want this workshop to be a burden. I just want to make sure that you're, spending your time wisely and getting paid for it in the student sense, which is being paid in points. Anyway, okay, so let's get going on this. So let's see, we are in inclined planes and curved surfaces territory today. I'm gonna start off just as normal, right? Go ahead and open up that annotation tool. Just get it ready. Turn on the drawing thing or the hey nice or the stamp tool, right? Let's see. I always promise that it's hide names of annotators, right? I'm happy to see who you are, but one of the incentives is that it is anonymous. So I have turned off the names. But anyway, everybody go ahead and grab a stamp, grab your favorite stamp from the annotation tool and just give it a stamp on the screen. Just stamp the heck out of my screen. Let's get it out of our systems just so that I know that you're ready, I'm ready, and we will get going. So 5, 4, 3, 2, 1. All right, let's keep moving on this. So a few things are that, well, I guess first, before we start, right, I want to kind of talk about the test, right? For those of you who have taken it, right, and retaken it recently, right, I guess let's open the test. I'm not actually opening anything right now, but I want to talk about your feelings about the test, right? I get a lot of grief about this particular question, understandably so, right? It looks like an envelope sometimes, or a I don't know, a 12-sided dice or something like that. If you have taken it recently, or if you just want to ask some questions about the test, what's frustrating you, what just doesn't make sense, right? I'd be curious to hear what you say. So does anybody have any questions, any statements about the test, anything that they don't feel like the workshop is quite addressing the test and they want more directed help? I guess obviously, right, that's a kind of a loaded question, right? Asking you to admit to struggling, right? But I think that this is a safe place. I feel like the last 5 or so questions are more difficult. I would agree, Maxine. Absolutely, right? In fact, I think that that's maybe by design. I know that, you know, Ella says yas, right? We got a second vote for that one, right? It's definitely harder, right? The second, it's kind of broken up into thirds, right? The first 10 questions are single axis rotations. The next 10 questions, 20 to 30, are you know, 2-axis rotations, and then the last 10 questions are still 2-axis rotations, but they're with really much more complicated shapes, right? So it certainly ramps up, right? And yeah, so I guess you are correct, right? That's not necessarily supposed to be, you know, something that I'm trying to trick you with, but yeah. So that is all to say, right, that there are a few things that I have, you know, a few resources that I've made available to you, be it the practice text, the practice exams, the models of the shapes that I'll show you, you know, the kind of tricks of the trade, be it the right hand, or not the right hand rule, well, the right hand rule, but the write a rule, right? Trick that we discussed last time. You know, hopefully these things are at least building our vocabulary so that we can improve our score, if not really blow it away, right? And if nothing else, right, this is more than just the test, right? This workshop covers a lot more than just the test. It's, you know, the skills learning for, you know, drawing things in 3 dimensions, right? Standards for drawing things and presenting things, and then also being able to practice for the test, right? So, you know, there's a lot that I'm asking of you in this, and I appreciate that, right? So let's keep going on this, right? You know, one of the things that you don't have the ability to do is shade the, you know, the shapes, right? That certainly helps a lot often, right? But that's, you know, something that I might suggest, you know, if you want to, you can kind of shade in for write a rule, right? That can sometimes help. Or, you know, if you want to use an annotation tool, kind of like the one that we use on Zoom, something that could be helpful, right, is this. I'll actually just go over here, right? Epic Pen, I think. Yeah, Epic Pen is a tool that you can, let's see, am I still sharing my screen? Yeah. It's a tool that you can use to annotate your screen, right? Oops, not that one. Epic Pen. Right, so you can always use this, right? Because since it's a digital test, you can draw over, you know, your screen and whatnot. That's maybe helpful, right? Whatever you need to do, right? To either practice or to make the test easier, I think that it's worth exploring. One other thing that I want to make clear, I haven't really discussed this too much, right? But is the fact that I've generated, and most of you have taken my CAD workshop through Gene 1400, right? But Onshape, this CAD software, is a program that I have used to create, you know, models of all of the shapes that are on the test. Now, I've randomized the models, right? I've named them different things, but these are all of the problems on the test, every single shape, right? There's 30 of these shapes. And you can practice with these, you can manipulate these and kind of see how they look, right? One thing that I'll make a note of, right, just for you, which is something that I did not take into account when are you able to see this? No, you aren't able to see this. You need this. Okay, here we go. Right? You good now? Okay. One thing that I'll share with you, which is not something that we really go over in the Onshape workshop, is this view options. You can do shaded without edges, right? Oops, actually, that's not the one. You can do that, but let's see. What is it? I think it's hidden edges removed. Here we go. Okay. So this is very much like the test, right? This is a representation, a manipulable representation of the things that you see on the test, right? And by clicking on the isometric view, right, you can kind of manipulate and play with some of these that maybe give you a hard time, right? Maybe you can go through here and try and find that darn envelope looking thing, right? The one that everybody complains about. But you know, I think that that's also a resource, right? I'm trying to give you as much as I can think of. But if you ever have any, you know, suggestions or questions, you know, hey, can I see this? Can I see the answers to this? Hey, you know what? Honestly, probably. I'm happy to work with you, right? So anyway, just kind of rambling while we kind of prepare and come off of the test and debrief off of that. But I also understand that we just came off of kind of a scary week, right? Hell week with midterms and exams, not to mention the fact that we are all now remote. So I guess that is all to say before we jump into this. I hope you all are great, right? Or at least I hope y'all are hanging in there, right? If you're not, please let me know. If for no other reason than to talk to somebody about it, right? Because I'm right there with you. All right. Inclined planes and curved surfaces. So today, what we're going to be introducing is something, you know, much more like the test, right? Very few shapes in the test. In fact, I would say maybe 2 or 3 shapes in the test are only made out of cubes, right? Or square faces. Whereas most of the other parts, right, are either, they include some sort of inclined, fundamental geometry, be it with an inclined plane or a curved surface. And so we're going to practice drawing something like that in isometric notation, right? So, there's 2 different types of views represented here. Everybody, just to kind of warm up those participation muscles, remind me what these 2 types of views are. We've got this type of view over here, and we've got this view over here. What are those 2 views, the view types, called? We've been practicing them recently.
Orthographic and isometric.
Very good, very good. Thank you, David. Right. So this is iso, right? Isometric, and these are ortho, right? And admittedly, let's see, are we missing any dotted lines? No, it doesn't look like it. Nope. This is the type of shape that you would expect to see, dotted lines if there was some sort of feature in there that was hidden, but these do not have those. ISO, we don't use dotted lines, right? So great. So we're going to be kind of combining these 2 viewing types, right? Just like we were with the isometric lesson, but we're going to start introducing more complicated features. So let's talk about that. First things first, find familiar or distinguishing faces, right? This is kind of the key to most of what we've been doing anyway, right? So this L shape, right? This L shape stands out pretty strongly, right? I would say that noticing that this is all the same shape, right, is, it's not only helpful, but it's kind of important, right? Then also, using the write a rule trick, right? That's kind of where this comes from, right? Is identifying these faces that are moving and maybe represented in different angles. So look at that. It's almost like I wrote this 3 years ago with the exact same intention that I have right now. Okay, so let's actually talk about that process, right? We just saw that shape and it disappeared, right? And if you can draw it, that's great. But just like any other one of these, workshops, let's kind of work through it together, and then we'll practice a couple things, right? So we've got our shape right here. First things first, for everything that we do, what's the first thing? It's not connect the dots. It's what? somebody draw it up there if they know, or you can shout it out and I'll draw it.
Establish the axes.
Wonderful, thank you. Axes, beautiful teal colored axes, wonderful, thank you. I'm going to draw some slightly bigger and color-coded axes, if you don't mind, but that's fantastic, right? So we've got our coordinate system, right? And now we need to start, with our isometric drawing. Now, what was my recommendation for starting with isometric drawings? Can anybody remember what the first thing is? And while we're thinking about it, I'm going to draw some of these coordinate frame references right here. So here's this, here's this. What was the strategy that we took with isometric drawings? Okay, eyeball, very good, very, very good, right? We needed to, let's see, how did I draw this? So nope, I drew that wrong. The view that we start with is usually most helpful. The most helpful view that we start with is the point closest to our viewing perspective, right? So that being said, let me actually concentrate and figure this out, because apparently I cannot talk and draw at the same time. There we go. Okay. And then we have this blue one. Okay. Looks good to me. Okay. So we start off with a viewing angle, and we choose the point nearest our viewing angle to start with, right? The axis, the vertex to start with that. So let's do that. Let's say that I first maybe move this up, because I know we're going to run out of space. This closest point to our viewing perspective, which I'm going to say our view point is kind of out here, right? This eyeball that somebody very helpfully drew maybe should be kind of up at an angle, right? But it's kind of pointing off in this direction, right? So so the nearest point to our perspective, I would say, is one of these 2 points, right? And so just for making a decision, let's start with this one, right? So first things first, with a point like this, let's identify that point on all of our orthographic views, right? So if I choose this point here, somebody mark the same point on this one and the same point on this one. And then let's finally, somebody can help me with this too. What are the coordinates of that point? Right. So of this point, right, where does it go in here? Okay, and I guess one thing to clarify, right? I see that somebody drew something right here, a little dot, right? That's fantastic, right? That's actually, and it's consistent with what was drawn right here, right? Usually what I would suggest is drawing it on the 0 layer, right? Down at the very bottom, right? So effectively where I guess it would be the red axis is 0, right? So if red is 0, then that point would not be up here. It would actually be down here, right? And same with this one, right? So those points are located, let me draw them one more time, here and here. Very good. Thank you to those of you who drew on there. Now, let's fill in these two numbers. What are the coordinates of this pink dot represented in each of these orthographic views? We can start off with yellow, then blue, then red. What do you think? Y'all are pros at this. 1. Nice. Okay. Let's see. Let's start there, right? So in the yellow direction, right, we have moved over 1, right? Perfect. We could can also say that here, right? And let's see, maybe draw that a little bit better. This is 2, right? So there's 1 in the yellow direction, fantastic. And then how many in blue? Well, 1, 2, 3, right? That's 1, 2, 3 in the blue. Very good. And we've got plenty of them, but my pen is bigger for some reason, my line width. So yes, 1, 3, 0. Very good. Let's plop that onto our coordinate system in our isometric view, right? Somebody want to jump right in there? Very good. Looks like we've got that, and somebody's already up and running with the first edge. So let's see. The first thing that we need to do is we need to start connecting dots that we know, right? Which by that I mean connect all of the dots that are square, right? Most of the shapes have some square pieces to them. Maybe they have some faces that are curved or inclined at some point, but most of the stuff that we're dealing with is square. So very good. Somebody's going to town with the blue pen. I'm going to kind of trace over it just to make it a little bit more bold, right? But bully for you. Let's keep going with this. And somebody help this person out, right? So we've kind of created this face, right? This square face right here. And then what? Very good. And I see the light green coming around the mountain. Let's see. So we've got this and this. Very good. It's kind of this one and this one and this edge right here down on the bottom. Very good. And so then, yes, we have, and I'll just let y'all keep drawing, right? And I'll point it out. Don't worry. Don't you worry. I'll point it out if it's wrong. But let's talk about something that has already been drawn, right? This thing right here, right? This vertical edge, right? It's kind of in this corner, right? And it runs up this and it runs up this, right? This orange edge, right? Would you agree that, especially in the way that I drew it, that point does not lie on a integer numbered coordinate grid point, right? It's somewhere in between. We have this kind of angled sloped piece, right? And so that intersection is not going to be standard, right? So before we get too far ahead of ourselves, what I want to do is I'm going to trace over the things that y'all have drawn over here that are square, right? And then I want to kind of take a step back. I'm going to, forgive me, I'm going to erase some of the angled stuff, right? Just for now. And then I'm going to, we're going to just go through this together. So thank you very, very much for those of you who drew those. You were correct. I will give you that, right? Spoiler alert, you were correct. But now let's just talk about this so that we're all on the same page, right? So in order to get from these points, right? Let's see, can I do a dotted line? I don't think I can. I think I have to do a pen. So a couple things, right? We know that these 2 points, right, especially this point right here, which is this and this, right, these 2 points are directly connected. That means that this point and this point are directly connected, right? So easily enough, just like the person who was, the people who were drawing earlier, right? Very good. Yeah, we draw that line right there. That's pretty easy to see, it's a connect the dots kind of a thing, right? But what about the stuff over in here, right? Over in the, let's see, can't see what I'm doing. Spotlight, here we go. These things, right? These lines that come on here, I would also say that, right, it's these points, these vertical edges are going to come up in a place that are not necessarily right, that we don't connect this one all the way, right? There's not a corner right here. Right? It's cut off right here. So how do we actually do that? Well, I mean, I think that some of you were already kind of getting at this earlier when you were drawing, right? But my suggestion is kind of draw maybe a straighter line than that. Draw a dotted line that connects an invisible vertex point, right? Something that it's not a corner, right? But we can kind of start drawing this angled grid system. And whoever drew that, thank you, right? That was correct. I appreciate that. That was good. So there we go. They're choosing the pink pen. Very good. And so once while we're drawing this thing, right, we're drawing up, 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 up until we hit this point, and now we're stopping, right? Kind of arbitrarily, right? This dotted line is kind of a construction line, right? And then later we can come back through and we can erase the construction and leave that there. Oh, jeez. Let's draw this edge now, right? We can kind of come in and draw this edge, which is connecting this new point that we've created and traced out. And then we kind of just keep doing the same thing, right? If we know that the line right here works up from here, from this corner, we work up to the dotted line, right? And then, yeah, no, somebody had it. Right? We draw that edge, draw this edge, and then there's one edge remaining if somebody wants to put the cherry on top. There we go, very good. So again, maybe not too surprising since we saw this in the very beginning, right? But our shape, right? That kind of strategy of taking square things and then, plotting those out and then, taking them and filling in the angled grid is a helpful way to approach that problem. Now, one quick thing, I'm going to throw in just a little monkey wrench to play around with this, right? What if I did this? Oof. One more try. Here we go. There we go. How about a half circle kind of shape around this back face? And I'm going to erase this line, right? So that we don't see it. So it's continuous. So that edge, the lack thereof, should give you a hint as to where this thing goes, right? What's this going to look like for our shape up here, right? Our view up here. Let me clean stuff up just a little bit, right? Very good. So we kind of have this caboose getting drawn on the back here, right? It's going to kind of just be a rectangle because the side profile of a cylinder, right, is a circle on one end, but a rectangle from the side, right? So while it's a half circle here, looks like a rectangle on this side, okay? Okay, so that's great. Somebody's already been trying it out with this bright green pen. That's great. I would say that let's, again, and this is what we were doing with, this grid thing, right? Let's find places where this thing intersects with vertex points, right? Points on our grid, and then we can actually go and draw those points and connect the dots, right? So thank you for drawing that. Thank you also for erasing that, because let's talk about it first, and then we'll pretty much redraw exactly what you did, right? But I want to kind of step through it. So we see that our blue axis needs to be extended into the negative direction, right? And if this is the case right here, then this point right here, this orange point, right, is at coordinate axis, let's see, 0 in the yellow, right? The in and out version of this. Actually, well, yeah, I guess it can be 0. It can be any of these points, right? Yellow isn't really important. Let's see, red is going to be 1 and blue is going to be -1. Where does that exist in here? Well, somebody want to draw it before I can change my colors? Let's see. Yeah, somebody drew it. Very good. Wonderful. Right? So it's right here. Right? So this gives us a little bit of a target to look for, right? Where before we kind of knew that it was shaped like this or something, right? Now we know for sure that this point is the furthest extent of where this reaches, right? So we know that this kind of tangent line right here is where it comes out to. We can use that to guide our drawing as we come up and around like this, right? And maybe we would see something of that thing right there, but that's a little bit more difficult to say whether that's something that we would see. I think we would see it. Okay, so Very good. Thank you for participating with that. I think that Zoom's annotation tool is just swell. So let's real quick see this thing, right? My animation attempt to kind of show our thought process, right? Drawing this first square face and then drawing the points out from them one space at a time, right? We can kind of keep building these edges, and then we lay this grid down, or rather connect the dots, right? So the purple line would go across here, and then we kind of make this intermediate grid by making our dotted lines, right? Then we can connect those dots, and everything is Gucci. So moving on. Let's draw this one, right? Let's start playing around with this. And then I think that I will say that I think the point is made. If we have any questions, then that's fine. I'm more than happy to answer them as usual. But let's see. Oops, nope. This is this one. I'm just going to start drawing our coordinate grid for us. Right now, does anybody have any questions? Questions, comments, or concerns about the nature of the test, about this subject in particular, or anything else? Well, that's fine. Anybody, how did tests go? Do we have any smiles? Smiles. It's done. We're done. Right? Done with the test. Okay. Maybe just a little bit of shell shock. No. Hey, we got a checkbox. I like that. That's that. Okay, my day is made. Thank you, checkbox. Whoever you are, I appreciate you. Hey, and we got some thumbs ups. Good. I'm very glad to hear it. Right. If you struggled last week, then you know there's more weeks. That's why there's 15 weeks in a semester. Okay. And if the question's about physics, boy, howdy, do you know somebody who taught physics or who? I'm just talking while I'm drawing, right? I'm a physicist, so you can always come ask me. Anyway, let's start drawing this, right? So here's my coordinate grid that I've drawn out, right? All set and ready. What I want to do is draw the eyeball. Let's see, I'm going to choose a view from this direction, right? So it's kind of up here and kind of, this is the back of our eyeball, right? Kind of up here. So again, let's choose a point. This is maybe more interesting, right? Because there's not a whole lot of choices like when we choose something like this, right? If I chose this point, where is that point on this one? Before, we had some options where we would, say that it's on the 0 level, right? If there was a vertical edge or something like that, right? But that's not the case in this one, right? This one is directly above the yellow axis, right? So let's see. We've got some points showing up right here, right? Does anybody want to dispute the fact that this is here? Let's see. If we drew that one here, right? That point would be where on this? Let's swap them, right? Somebody draw the green one on here and the pink one on here, right? Where do those points correspond? Let's also do this, right? This might help. Top, right, front, ear, airlines. I don't know. Okay, so where are they? Okay, good. So we've got a green spot here, right? So that's where this green spot goes. Very, very good, right? It's kind of smack dab in here, right? It's actually any point along this edge, right? Actually, it's not any point along this edge. What am I talking about? It's, come on, where's my Control Z? Uh-oh, that's Control X. What are you doing? I would say that this thing needs to move over here, right? Oh, goodness. Over here, right? Because this point, right, is kind of lined up with this point, right? And then similarly, right, this point like this. So actually, this is something that we didn't really go over too much in the orthographic views, but right, when we draw our shapes in this order, right, in this configuration where it's the top, the right, and the front, right, we can actually see that these points are going to align between our views, right? So this one kind of lines up here, and then this one lines up right here, right? So let's see. Let's do the same thing with the pink point, right? The pink point is going to be, well, if we kind of line it up right here, it's going to be in the same spot as the green one, right? Then we move over here. Let's see. This one is the green point, or the pink point is directly above the yellow line along the red axis. I say above, following the red axis, right? So if we go from the yellow axis, and we go up according to the red axis, right? Then that pink point is right here, right? Okay, interesting. So let's keep going on this, right? Get rid of my tacky joke, my tacky Frontier Airlines joke. I don't even work for Frontier Airlines. What gives?
Mo, I have a quick question before we move on.
Yeah, what's up?
So for the right view, why is the pink point right on top of the green point?
Right. Not right, correct. Yes, not left or right, it's correct. So yeah, let's actually maybe take a look at this, right? Maybe I can do something more helpful than, oh my goodness, than what we're doing right now. Ooh, how do I do this? How do I get rid of those? Well, can I save? What does that do? Save this PNG. Well, we can redo it. Let's see, clear all drawings. So, oops, no, don't show it off. Let me quickly create this in CAD so that we can all see it. We've got a little bit of time. Maybe a quick review of how to use CAD, right? So the reason why we're doing that is because when we project our edges, right? And this is maybe a little bit of a spoiler alert of the thing that we're looking at, right? The end goal of what we're aiming for. So we've got our part, and maybe this is one of the views, right? Let's see, maybe I can do this like this, and like this, and like this. Don't worry, I'll get there. Here we go. Very good. So the top view of this thing, right, is looking like this, right? Here we go. Okay, so we got our top view. When I go rotate it down, our side view looks like this. This is not very helpful, right? It's kind of a confusing perspective. But when we look off to the side, I rotated the wrong way. Let's see. Front, left, and top view. I see. What did I do? Usually this one is called the side, I think, is maybe what I'm getting wacky on. Okay, so effectively, I shouldn't have called it the right view is the first thing. Let's do that. Let's fix that. So instead of the right view, let's call it the left view. Right? But again, one of the sides, This is the top view. This is the front view. So if we're moving from, say, the top, right? I'm going to try and do this as best I can, right? Moving down to view the left-hand side, right? And actually, this is the question, right? So your question was, if these two points, right? These were the green and pink points on our part, right? These 2 points that I've highlighted, right? If these 2 points look like this when we're looking from the top view. When I rotate it down to look at the left view, you see how they overlap now, right? When we have kind of looked, when we look from directly over on the left-hand side of this thing, right, the points line up, but let's see, not this the wrong way. But again, when I looked from the top view, they are kind of at an angle from one another. So let's actually do something else on here too. Turn perspective on, right? I can actually see kind of more of a perspective view with this, right? So again, top view, right? This is kind of closer things are zoomed in, further things are kind of away, right? More like how our eyes work. And then when I rotate it down, those 2 points are going to overlap one another, right? When I rotate it this way, they again become unoverlapped, right? But that's the thing about these points along, say, the x-axis, right? You see my x-axis here is red, right? If they are in line with the x-axis, then when I am looking at a plane, the left or the right plane, which is normal to, right? It's normal to or perpendicular to the axis that I'm interested in, right? Then those points are going to overlap just by nature, right? That's how it goes, right? Similarly, for this point and this point, right? Those are aligned along the z-axis, right? And so if I'm looking down the z-axis, right, in either the bottom view or the top view, right, those points are going to line up, right? Does that make sense?
Yeah, that makes a lot more sense. Thank you.
Yeah, of course. Good. Yes, and Brendan makes a good point, right? It's orthographic and isometric views, right? This is a perspective view using still or isometric. You know, this is kind of the isometric view is kind of where it's positioned, right? Oops, let's see. But if I take off the perspective view, here we go. Yeah, orthographic views are those points will line up if they're on the same axis. Okay, so yeah, ultimately this is what we're going for, but let's draw it real quick. Clear all drawings. Let's see, we chose this point, and again, I'm going to, let's see, I need to collect my thoughts. Here we go. Here we go, we're going. Point right here, point right here, point right here. Point right here, point right here, point right here. Right? If the red axis is up, the yellow axis is this way. I don't know if that was how it was before, but that's fine. And then the blue axis is this way. Right? Then what does it look like? And so let's start by somebody drawing. Let's start drawing the yellow. I'm sorry, the pink and the green points on this kind of grid without grid points. And I'm going to continue to draw these axes just to make sure that we are all on the same page. Oh. It's a lot of work drawing these dang axes. Okay. So pink point is, what are the coordinates, right? I'm just going to start drawing them out. Right? Pink point is on, let's see, like this. Green point is this one. Somebody go ahead and just help me out here. What are the coordinates of these pink and green points? We got red first. Oops. Red is the first digit. Yellow is the second digit. Blue's the third digit. Okay, and it looks like somebody's starting to draw these right here. That's fantastic, right? So I would say that this dark blue spot that somebody drew is the green point, right? And the coordinates of that are up 1 in the red. Very good. So that's this one, 1, 1, and actually, wait, let's see. I would say this is 1, this is 1, right? Because the yellow, yes, is up in that direction, right? Is up 1. There's something up with the green one though. We had 1, 1. I think there you go. We need a 0 right there, right? Because it is, let's see, in the yellow direction, green is lined up at 0, right? You see that? Green is at 0 with respect to the yellow. So good. So we got 0, 1, 1, 0, and then I would say, yeah. So it's a little bit harder to see because I didn't draw designations right on this one, but yeah, I would say that the green is at 2 on the blue line, especially now that I've made demarcations. Thank you. And then that means also that for the blue line, right, or for the blue axis, pink also falls at 2 on the blue, right? So that means that pink is somewhere around here, right? I'm going to draw a few more points, right? And I want you all to translate them for me. Let's see. This is the why did I draw my green point up there? Was that me? That is not where it goes. That was me. Let's see. I don't know what I was doing, but anyway, it's right here. And right here. Somebody draw an orange point there for me. We're going to just kind of complete this front face with different points, different kind of coordinate points. Right? So purple is going to look like, well, it's going to also be overlapping, right? Because along the y-axis, these things are all in the same line. Then this one's right here. And finally, cyan. It's going to look like something like this. Right? So it looks like we've got an orange. Very good. We got an orange up there on the top. Right? Something like this is that point. Right? And I'll start drawing some grid lines, right, just so that we can see this a little bit better. Very good. Right? This one's a little bit harder to see, right? But our grid, oops, kind of looks like this, yeah. Right? And so we might be a little bit cattywampus here, but that's fine. A little green checkbox. That means we're done, right? Very good. Well, let's finish this off. We're almost done here. So if I kind of rearrange so that we can more appropriately place our parts. Come on. Whatever. Y'all got it. It was my bad drawing, right? My bad grid. So here's that, and then we finally have the purple point, which was up there, and I had erased it. It's right here. Right? So then if we were to kind of erase these guys, just since they're a little bit messy. Oops. What did I do? I'm really struggling with this annotation tool here today, y'all. If that's the case, then in, I guess, maroon, ugh, what a gross color. Let's draw this out, right? how does this face look in here? Well, so orange is connected through an arc to purple, right? Kind of like something like this. Good. I liked the dotted lines, right? That's fantastic. This dotted line got drawn right here, right? So if this is the case for this kind of shape, right? We kind of see a Pac-Man symbol, oops, on its end, right? And then we need to simply draw, it's like a cylinder, right? These are straight lines that follow the blue axis back, right? At whatever level they are along the red and yellow axes, right? So perfect, right? Somebody's going for it, right? There's that, there's this one, very good. And I actually drew this one as well, but I would say that based on this this view over here, the left-hand view, there are no lines on that edge, right? It's a curved surface, right? And so rather than drawing this edge where, you know, this dotted line would be, you know, crossing like this, this gets a little bit more complicated, right? The line is actually going to exist where the edge of the part actually ends, right? Along that edge, right? So this is kind of weird, right? If we, let me use my move tool, right? If this thing is up here, right, this is the line that follows along the blue axis, right, from this coordinate point. We're going to kind of take that line until it goes tangent with, oh, now we've gone too far, right? So we kind of go tangent with our circular face, and now we're good, right? We've drawn our part, and then we can finish it out exactly. Very good. Right? We draw that back edge. Okay. So as usual, right, I can talk all day if I need to, if I want to, but right now I think the best thing to do is to just let you go on those practice exercises, right? So with that, I'll again open it up to any questions that you have, but I want to remind you, right, those exercises, right, the reason why I ask you to spend an hour on them, right, is not because, you know, I'm not looking for, obviously, I'm not looking for correct answers. I'm looking for experience, right? Practice drawing these things, right? Do yourself the favor and, you know, spend, if you are allotting an hour, right, which you need to anyway, make sure that you're making that hour count, right? You're learning something new here. So what you put into it is what you get out of it. So we can shade these things. It's not quite as simple as before where we could, you know, shade each direction, each plane that's in a certain direction, a specific color, right? We kind of have gradients now, but that can also be helpful if we are trying to understand how this shape looks in 3 dimensions. I'm going to finish this up and I'll download this video, post it onto our Spatial Viz Canvas course, right? You'll see the assignment here shortly from me, and then, yeah, business as usual for this week. If you have not taken the spatial visualization test again, right, the retest, please do so. I would say that do it sooner rather than later, right? It's not due yet, but then again, I'd rather you get it done now before another scary week creeps up on you, right? So go ahead and get that done. Get any overdue assignments for this course done and turned in so that your new test score is eligible. Again, if you have earned if you take the test and you have earned, you know, 20 out of 30 or greater, right? That's 5% of your grade. That's fantastic, right? You can stop right here and you have earned that 5%. Right? You're already halfway, actually now more than halfway through the entire workshop series. So if you keep going, you get an extra 3% extra credit, right, on top of everything. Right? But yeah, again, y'all are busy people. I appreciate that, and so thank you for spending some time with me. Okay. Any other questions before I let y'all go?
I have a quick question to ask you.
Yeah. What's up?
Is there any additional practices that we can do to prepare for the test, or is just doing the homework and exercises just good enough?
I would say that doing the homework and exercises is probably good enough. If you really want to kind of dive into it, if you're really uncomfortable with certain problems, I would encourage you to maybe um, what's it called? Jump into Onshape, right? That those links that I have for the Onshape shapes of the test, and you can manipulate those. Maybe kind of play around with how those are lined up and see how maybe you'd recognize one of them, like, oh yeah, that's that envelope looking one, right? And you can play around with it. But more than anything, I would say just kind of practice with the practice exams, doing the exercises, right, and the homeworks and stuff like that. I think that that's probably the best. If you're really looking for practice for the test, go through all of the workbook exercises for Unit 3, right? That was the 1D and 2D rotations. That's the test, right? That's the thing that we're testing you on. Everything else is kind of adjacent to that. But yeah, those are probably the best exercises for something like that. Okay.
And Onshape the link is found on Canvas, right?
Yes, it should be. Let me double check that that's the case. Canvas. It should be in a section in modules. It says tools, grid paper, and useful resources. And one of those things should be, yes, in extra stuff. It says Onshape. So let me throw that into the chat right here, just for solidarity, right? You'll see that on the bottom of this page, right, is extra stuff, and the extra stuff in there is the Onshape modules of PSVT parts that you can go and take a look at. Right?
Okay, thank you.
Yeah, no problem. No problem. Alrighty. All right. Very good. We'll see you around. Thanks for your question, Jordan. I appreciate it. And
You're welcome.
we'll see everybody else around, okay?
Right, see ya.
Bye.